Okay, so just give you a quick overview of this problem. I'm going to read it out loud to you again, and if I need to demonstrate something, I will. So let's listen very carefully. Just like any other problems, I highly suggest that you read it through one time first. It says, with the wind, an airplane travels 1,120 miles in 7 hours. Against the wind, it takes 8 hours. Find the rate of the plane in still air and the velocity of the wind. So clearly you see that with the wind, the airplanes tend to speed up, right? Because the wind is helping the airplane. And vice versa, if the plane is flying against the wind, it will slow down because you have to fight against the wind to fly to your destination. Now let's think about this for a moment. Based on the problem, I told you that 99% of the time, right? I stated this so many times, I hope you take my words for it. But technically 99% of the time, when you read this very last question, it will almost tell you what you need to define to solve the problem. Because the last statement right there or questions will ask you or request that you need to find this or that. And because if they're asking you to find this or that, you don't know what it is yet, right? Therefore, you have to declare. Every time you don't know something, please don't feel like, I'm not going to ask. Ask. In this case, for our problem, if the problem asks you to find something you don't know it, declare it. Say, I do not know this, so therefore I need to define a variable to represent this. In this case, what is it that we don't know?
The rate
of plane.
velocity.
You're not being very specific. The rate of plane in still air. And the wind velocity, which is the speed of the wind, right? So with that two pieces, what should we declare now? What do you think?
X and Y.
Okay, let's declare. X is
Rate of plane.
rate of plane. What?
In still air.
Oh, I need to do this, otherwise it's gonna mess up. Oh. Okay. I thought I'm having rate of plane in still air. Very good. Okay, what else?
Y equals velocity.
Y is the, let's change the velocity. Sometimes people have a hard time understanding what velocity is. Let's just make it simple. Speed, right? Okay? Or rate of the wind, right? Okay. So, do we have the two variables to represent what I don't know at this current point in time?
Yes.
Okay. Now look, we also know something. That with the wind, the plane travels 1,120 miles in 7 hours. What's already given there based on that first sentence? Yes. The distance and the time. Interesting. Wait. Didn't we just learn something about distance, rate, and time? What is that formula again?
D equals to R times T.
Oh, D equals to R times T. Very good. So if we have the distance and we have the time, what can we find? The rate. But don't we have two different kind of rates? The rate with the wind and the rate against the wind, right? So now we have to create two cases. One case is with the wind, and the other case is against. Is that true? Okay, so with the wind, how long did it take to go with the wind? How long did it take? 7 hours. So don't you write this. The distance is 1,120 miles. The rate in this case, since we don't know, we just leave it as R. And the T in this case is 7 hours, right? You see that equation right there? Notice I'm trying to find out how fast did the plane go. I have the information, now I have to figure out how fast did it go with the wind. So if you solve for R, what is it?
X plus Y.
Not yet. I'm still solving to find the rate of the plane with the wind divided by 7. So divided by 7 here, what is the rate? How fast did it go?
160.
160 what? Miles per hour. Very good. So this is the speed with the wind, right? Agree? Notice how we still have to use D equal RT all the time for this particular problem, for this kind of problem anyway. Let's do the case against the wind. Against the wind, how long did it take the same plane to go? 8 hours. So it's still going 1,120 miles, but this time it's going for 8 hours. You see it? I'm still using the same equation, but different time because it's going against the wind this time. So divided by 8 both sides, what is the speed?
140.
140 miles per hour. So you're probably going to ask, why is it so important I need to find the rate? First of all, it has to do with how the planes respond in the air, with the wind and without the wind, or actually with the wind and against the wind. So think about this. I already demonstrated to you the scenario where the plane is going with the wind. If the plane is going with the wind, it has to go slower or faster?
Faster.
Faster means the speed will increase, right? Is that true? So wouldn't you say that I have two variables here talking about the speed of the plane and the speed of the wind? If I want to describe a case where the plane is going faster because it's going with the wind, how do you think I should involve these two variables to describe that? Yes, go ahead. Thank you. The speed of the plane plus the speed of the wind will that speed up the plane. To how fast? How fast? What did we just find out about the speed of the plane? 160. Very good. Didn't we just find out? That with the wind, it's going 160 miles per hour. Okay? On the other case, we have the plane going against the wind. So how do you describe that case where the plane is going against the wind? Yes, Brandon. Thank you. The plane speed minus the wind speed. Is that going to get you a slower speed or a faster speed? Slower to what? 140. Do you see how we have to find this here? Notice I'm using information that's already given to find that speed, and because I am declaring variables in terms of speed, I make sure that everything has to be speed. You see it? Every single one here is talking about the rate, speed, how fast something's going per hour. So I have my two equations. What is your next step? It's going to be, yes?
Choose between elimination or substitution.
Oh, see? So it's automatic. Choose between elimination or substitution. Which is it? Elimination, yay. Why? They're already lined up. So if I have decided to go elimination, what is my next step now? Yes?
Yeah.
Not even before that. Yes? You got to choose. Which column would you like to eliminate? Remember, if we're choosing elimination, we have to get rid of something. But to get rid of something, you have to pick which one. Which one is it? Oh, let's say Y. I'm going to choose Y. And if I choose Y, do I need to find the LCM here?
No.
No, because they're already the same. But I have opposite signs here. What is the operation to get rid of these? Add. Very good. So I'm going to be adding them. If I add, I'll just use a different color here. If I add, do I add just one column or every single column? Every single one. So I add. That could become 2x equals 2.
200.
2y. No.
What's 160 plus 140? 300. Alright, so I would divide both sides by 2, correct? X is 150 miles what? Per hour. And what did we just find out? That the rate of the plane in still air is 150 miles per hour. But then wait, they also ask you to find the wind speed as well. If we know what X is, how do we go back here and solve for the Y?
Plug it into one.
Right, very good. Any questions?
No. Second one.
Does it have to be the second one? Or it could be any? Any. Does it have to be the second? Just a second. Let me show it to you. If you take 150 and plug it back to X, 150 plus what is 160? 150 plus what value is going to give you 160? 150 minus what is going to give you 140?
10.
You see, both ways, it's the same, 10. So therefore, Y is 10 miles per hour. So you can now conclude that the problem tells you that for the wind speed, it's only 10 miles per hour. And the plane speed without any wind affecting it is 150 miles per hour. So with the wind, it will speed up to 160. With the, going against the wind, it will slow down to 140. Any question on this? And this particular problem here will also work on the river problem too. Boat in the river, going against the current or with the current, the same concept. Okay? You just have to make sure you know. And by the way, you're still using distance equals rate times time. Okay? All right.